In part 1, we made a claim. The two-speed interference motif that Rebbin and colleagues found in cortex should not depend on biology at all. Build it from a fast-directed channel and a slow shared field channel with no neurons and no ion physics, and its measurable signature should still appear. The decisive fingerprint is precise. The synchrony versus distance ripple should have a wavelength that scales as 1 over frequency, with the constant fixed by the two conduction speeds. Those speeds, Gen 26 and Gen 108 mm per millisecond, come straight from the paper. At 40 Hz on a faithful 4x2 mm array, synchrony does not decay smoothly. It rings, a fast near-field fall-off, a dip, then a rebound. Fitting the shape gives a measured wavelength of 2.48 mm against a predicted 2.3, an 8% miss on a quantity that appears nowhere in the code. Sweeping frequency from 20 to 55 Hz, we regress the emergent wavelengths against 1 over frequency. Measured slope 0.20975 versus predicted 0.20919, intercept near zero as theory demands, R squared of 0.2991. The lowest frequencies were correctly flagged unresolved rather than forced. The same ceiling the real dish hit. Turn the slow channel off, and the rebound collapses from 0.18 to 0.01, leaving a clean monotonic decay. So the ripple comes from the slow shared field channel, not geometry, wiring, or the estimator. In tissue, this is patterned stimulation over critical days. Here, it is a single flag. A fair objection. This ripple resembles a Mexican hat, which many static, frequency-free mechanisms can produce. So we tested a signature no static kernel could carry, dependence on the speeds. Fixing frequency and sweeping the slow speed toward the fast one, the wavelengths sit on the identity line, and the ripple vanishes exactly as the two speeds converge. Together, these two results pin it. The wavelength depends on both frequency and the speed difference, exactly as the formula demands. A static, fixed-length kernel has neither dependence by construction, so in silico, the frequency and speed scaling is a fingerprint of two-speed interference specifically. Gone honest caveat. The resolved gate is noisy near threshold and drops the occasional accurate point. The trend and the vanishing are robust. The per-point flagging is not surgical. Rebbin's second claim is generative. Activity-dependent pruning, biased by the field, should build spatial structure. Scoring units by coherence and pruning the lowest half, survivors form two bands, hugging the short edges with a depleted middle. Turn the field off, and they collapse to a single central blob. The anisotropy is a product of the field, not of pruning alone. So what does this establish? The two-channel motif reproduces Rebbin's full observational signature, the ripple, its scaling, its speed dependence, and the developmental banding in a substrate with no neurons. The signature is a property of the abstract computation, realizable in message passing and shared memory. This is the double edge. Good news for neuromorphic and multi-agent design. The interference motif is a general primitive with two knobs. Cautionary news for the biology, because a neuron-free substrate reproduces the signature and its scaling. Seeing that fingerprint in cortex does not by itself identify ephaptic coupling as the cause. What it does not do, it says nothing about ion channels, astrocytes, or real cortex. This is a model organism for a mechanism, one abstraction beyond a cell culture. Its worth is that it is fully observable and fully perturbable. Analogy, not homology. Every affordance we used, toggling the field, enlarging the array, tuning speeds, is one biology lacks. The experiment that would pin ephaptic causation in tissue is the one Rebbin's group named as future work. Drive cultures with pattern stimulation and watch the bands move. In silicon, that was a config change. In the incubator, it is the real frontier.